In severe weather situations, we typically want the dew point to be on the higher side, at least relative to the temperature. So let's say we have a temperature again of 75 degrees Fahrenheit. Our air temperature at the surface is 75 degrees Fahrenheit, but our dew point is 40 degrees Fahrenheit. That means that air is going to have to cool all the way down to 40 degrees to become saturated. That indicates a fairly dry atmosphere. One of the basic tenets of meteorology is that warmer air holds more moisture. So in this case, even though if we were to cool down this air temperature at the surface down to 40 degrees, the actual amount of water vapor in the air is not changing. But because we have to cool this air all the way down to 40 degrees Fahrenheit to get to that point of saturation, that indicates that's a much cooler temperature, of course, and it technically doesn't hold, quote unquote, as much moisture as, let's say, a dew point of 65 degrees Fahrenheit. So let's say that same scenario, we have 75 degrees surface temperature and a dew point of 65 degrees Fahrenheit. Now, we don't have to cool that air all that much down to 65 degrees Fahrenheit to get to that point of saturation and to reach the dew point. That indicates a much more moist environment than this environment on the left here. Generally, we want our dew points to be on the higher side for severe weather, especially relative to our temperature. Because let's say if we have a dew point, let's say our dew point is 75 degrees Fahrenheit. That at the surface just by itself is a pretty high dew point. But if we have a temperature of, say, 105 degrees Fahrenheit, our air temperature at the surface is 105 degrees Fahrenheit, that's still quite a ways we have to drop to get to that point of saturation. And that's still generally a relatively dry environment. But let's say if we have a dew point of 75 and our temperature is, let's say, 82 degrees Fahrenheit, that's a much more moist environment because that temperature, that spread between the temperature and the dew point is not that large. And for tornadoes to occur, we want that temperature dew point spread, as we call it, to be on the lower side, generally within about 20 degrees Fahrenheit or so. Now, just a quick note, the dew point can never be greater than the air temperature. So if you have an air temperature of 75 degrees Fahrenheit, your dew point can never be, say, 80 degrees Fahrenheit. That's just not possible. There are some very special situations in the atmosphere where this can happen briefly, but for most purposes, and really all purposes within severe storms forecasting, you will never see the dew point be greater than the air temperature. Our typical ranges for severe weather, as far as the dew point goes, most of the time you want to see those dew points in the 60s Fahrenheit. That typically is rough rule of thumb. Again, it varies based on the air temperature and some other factors in the environment. There's been severe weather setups that have happened with dew points in the 40s and 50s, but usually this is when your air temperatures are in the 50s and 60s, so that temperature dew point spread is on the lower side. This happens a lot in the fall and winter months when simply the air temperatures are often cooler, they don't hold as much moisture, so you don't need as much moisture in those off-season setups than you do in, say, the spring, when our moisture return is more robust and our air temperature is greater overall. It's all dependent on, and it's all relative to the air temperature. But most of the time, for most of your robust severe weather events, those dew points really need to be up in the 60s, particularly above about 65 degrees Fahrenheit or so, mid to upper 60s into the 70s, to really have robust moisture, especially at the surface. When we're talking about all of this, we're talking really focusing on the surface, but moisture is important as you go up in the atmosphere as well. But for the surface, that dew point needs to be relatively high relative to the temperature, and in most cases, for most robust severe weather events and tornado outbreaks, you want that dew point up into the mid to upper 60s, even into the 70s.
Storm chasing is already tough. Learning alone makes it tougher. Discord community link in description.
Another caveat to this is also elevation. Air at higher elevation does not hold as much moisture as air at lower elevation. So if we have, let's say, the same dew point at Oklahoma City as we do at Denver, let's say we have a dew point of 60 degrees Fahrenheit at both of those locations. That 60-degree dew point is going to be a lot different at Denver than it is at Oklahoma City, because Denver, that air is at much higher elevation, so it doesn't hold as much moisture by nature. So the fact that you have a 60-degree dew point indicates a very moist air mass, perhaps a much more moist air mass relative to what the air mass would be at Oklahoma City, which is at a much lower elevation. So oftentimes in the higher elevation areas, severe weather can happen with much lower dew points than the same setup at a lower elevation area, say the southern plains. Now, where do these higher dew points come from? Typically, for most severe weather events in the plains or the Midwest or Southeast or Mid-South, it's going to come from the Gulf. That air above the Gulf is fairly high in moisture content. Those dew points are usually fairly high in that air mass over the Gulf. As these severe weather events get going, the winds in the low levels can start transporting the air that's over the Gulf that holds those higher dew points up into the inland areas of the U.S., again, the plains, Midwest, Mid-South, Southeast. And that's really our major moisture source for where these higher dew points come from. You can have some exceptions. Basically, if you're in the, say, Pacific Northwest, you'll get some of that moisture off of the Pacific Ocean. If you have Atlantic severe weather events, you can get, oftentimes the Gulf moisture will be our main moisture source, but you can get some enhancement from the moisture off of the Atlantic. But for the majority of severe weather events in the central U.S. corridor, that moisture is going to come from the Gulf down to our south. That's our main moisture source region for those higher dew points for most severe weather events in the U.S.
Remember to check out those links in the description below, and then watch another video.